This tutorial video will demonstrate an extension to the algebraic method that allows you to use it to balance redox reactions. This extension requires being comfortable with a bit more ambiguity about whether something is a reactant versus a product. So here we have a redox reaction in a basic environment. Because it's basic, this means that we can assume that we will always have hydroxide ions as well as water available in the reaction vessel. As a result, we can add those two to either side. I'm arbitrarily picking to add this to the reactant side. And so in doing this, we've added in what we know will be in the final balanced reaction, but we don't necessarily know exactly where it's going to be. In order to get this balanced out correctly then, we still apply the same steps in the algebraic method with one extension. So we attach our dummy coefficients, A, B, C, D, and E, and now we're going to write out equations for every element as well as the charge. So we'll have an equation for oxygen, we'll have one for hydrogen, we'll have one for phosphorus, and we'll have one for the charges. So everything works out completely identically. We have A plus B equals 2E. For hydrogen, we'll have A plus 2B equals 3D plus 2E. For phosphorus, we have 4C is equal to D plus E. And for the charges, we take into account the sign of the charge. So however many copies of hydroxide we have, that's going to add a -1 charge. So minus A equals negative E. And so if this were ready to actually step through the remainder of the algebraic method, where we do our thinking step of picking a value for one of our 5 dummy variables, and in this case I'm going to let E be equal to 1. So now it's just a matter of substituting through and figuring out what our values are going to be. Well, if E is equal to 1, then A also has to be equal to 1. The reason I chose E is because E allows me to get A. If I have E and A, I can determine a value for B. So B also has to be 1. Given that I have values for A, B, and E, I can determine a value for D. And D will be equal to 1/3. And because I have values for D and E, I can find a value for C. That is also going to be 1/3. And as you'll recall, we multiply to get rid of our fractions. So we'll multiply by 3. This gives final values of A equals 3, B equals 3, C equals 1, D equals 1, and E equals 3. So now we just replace all of these. So A equals 3, B equals 3, C equals 1, D equals 1, and E equals 3. And so it's left as an exercise to the viewer to verify that this balanced reaction satisfies all the requirements of balancing a redox reaction. That the mass is all balanced and that the charges are all balanced.